Hi, this is Gabby, and today we're going to be reviewing how to graph sine functions. So first, what we want to do is we want to identify the different parts of our function, but we're going to start with our midline, which is positive 2. So from the 0, we're going to go up 2 and graph a dotted line to represent our midline. Now, because our amplitude is 3, we are going to start from the midline and go up 3, and then start from the midline again and down 3, drawing a line to make sure that we identify our range restrictions. Now, when graphing, we want to make sure that we are able to identify our intervals. And by doing that, we must find our period, which is found by the equation 2 pi over b. And in this case, our b is 2, leaving our period to be pi. So what we would do from that is we divide our period by 4, leaving us with intervals to put along our x-axis, which are already there. Now, from there, we are going to look at our phase shift. Now, because there is a subtraction symbol, that means we're going to the right pi over 4. And because it's a sine equation, we start from the midline. Now, to continue, we use our period knowledge and we go all the way over pi, because that is our period, and we graph again at the midline, since as we see, a sine function always begins and ends at the midline. Now, from our starting point, we are going to go over one interval, go up to the amplitude, go back to the midline, another interval, go down to the minimum, go over another interval, back to the midline, then connect the dots, and there you have it. So next, we are going to be turning this into a cosecant function, which means that we are going to be making our asymptotes. To do that, we're going to take our period and divide it by 2. So in this case, it would simply be pi over 2, which means that every pi over 2, starting at our beginning point, we're going to make a asymptote. So as you can see, we went pi over 2, and then we made our orange asymptote, and then we went back to our beginning to make sure we marked it as well. Then we went another pi over 2 and marked another asymptote. Now, in a different color, we are going to create parabolas at the maximum point and the minimum point. Now, as you can see, with parabolas, we want to draw 2 arrows at the ends and make sure that no matter how long the arrows go for, that they never touch the asymptotes, because those are no touch zones. And there you have it. Bye. Hi, this is Gabby, and today we're going to be reviewing how to graph cosine functions. And this specifically actually includes a reflection over the x-axis. So first, we're going to start by identifying what a normal and a reflected cosine graph would look like, just so that we make sure that we know what our end goal should look like. Now, next we're going to start by identifying our midline, which in this case is -1. From there, we're going to use our amplitude, which is 2, to go up from the midline 2, and down from the midline 2 as well, so that we can understand our range restriction. Next, we are going to make sure and double check that we have no phase shifts. So then from there, we're going to find our period by using the equation 2 pi over b. And in this case, b is 4, leaving us with a period of pi over 2. Following that, we are going to start by marking our beginning and end points of our graph. So our beginning point, since there's no phase shift, is going to be at the bottom, which is our minimum, at 0. Now, because we know our period is pi over 2, we're going to move pi over 2 to mark our endpoint, which will also be at our minimum because it is a cosine graph. In usual circumstance, it would be at the top, but because this is reflected over the x-axis, we will start and end at the minimum. Now, we will go over one interval to the midline and then continue over another interval to get back to our ending point. Now, what we will do is simply connect the dots, and there you will have it. That is one period of a reflected cosine graph. Bye. Hey guys, this is Gabby, and this is part 2 where we're going to review how to graph secant graphs. So first thing we're going to do is establish our asymptotes, and we're going to do this by taking our period and dividing it by 2. In this case, I multiplied it by 1/2 because it is a fraction. Now, what this is going to tell us is our interval between each asymptote. Now, for each asymptote, you're going to want to put them around the surrounding minimum and maximum. And because our interval is going to be pi over 4, that means that from every minimum or maximum, pi over 8 should be another asymptote. So as you can see, from our maximum and minimum, I went to the left and right pi over 8 and created an asymptote. which means that from one asymptote to another, there is a distance of pi over 4. Now, what our asymptotes are representing are lines that our parabolas that we will soon make cannot touch. Now that we have our asymptotes, we're going to start on our parabolas. Now, these are pretty simple because, as we know, our parabolas always start at the minimum or maximum points and simply go up towards the asymptotes, yet never touch them. And that's it. That's how you graph them. Bye!
Alright, so for the unit circle, we have our trig definitions from SOHCAHTOA, but these need to be generalized because if I asked you to find the sine of 30 or sine of 60, that wouldn't make sense because you need the triangle. So to do that, we use the unit circle. We have our radius here, also called the terminal ray. Theta is the angle between that and the x-axis, and then we also have our point xy, where the radius intersects the circle, and then we have our x and y legs to make a right triangle. So we can find this. So sine of theta is y over 1, cosine of theta is x over 1 using our SOHCAHTOA. So that also means we have a convenient way to express these two using this unit circle. So to take advantage of this, we use the special right triangles. So this is the 45, 45, 90 triangle. So we can see that the sides are the legs are proportional to root 2 and the hypotenuse is proportional to 2, assuming the angles are like this. So we need the hypotenuse to be 1, so that a needs to be 1/2. So based on this, we can obtain these definitions because the sine would be this y, so it's root 2 times 1/2 root 2 over 2. And same for cosine, and then obviously sine or tangent is sine over cosine, so they just cancel out because they're the same thing. Then we have our 30, 60, 90. So this is like the same logic. So you take the 1/2 is a because we need the hypotenuse to be 1. So then if you take the sine of 60, the y is just root 3 over 2. Cosine of 60 is 1/2. Then for 30 it's reversed. So the sine of 30 is 1/2. The sine of 30, or the cosine of 30 is root 3 over 2. And then for tangent, you just have to divide the 2 and then mess around with it. So yeah, using that, we have the unit circle, and we can fill it out by just going opposite directions using their reference angles. You just have to be mindful of the signs because when it's in quadrants 3 or 4, sine is negative. In quadrants 2 and 3, cosine is negative, and in quadrants 2 and 4, tangent is negative. And then quadrant 1, all of them are positive.